Iceland is a great place to see exactly how the planet's inner heat is able to transform the surface of the Earth. Magma usually lies hundreds of kilometers beneath the surface, but here in Iceland, it's much closer. And that has a dramatic effect. Sulphurous fumes and bubbling hot pools hint at the power that is just beneath the surface. There are naturally heated pools everywhere on the island, which makes going for a dip something of a national pastime. But the people here might not be quite so relaxed if they knew exactly how the water gets heated. Right beneath them is a seething mass of red-hot molten rock. Just 20 kilometers beneath Iceland is a vast column of superheated rock called a plume. Recently, the shape of the plume has been mapped. It's 100 kilometers wide and at least 600 kilometers deep. Created more than 50 million years ago, the plume is sustained by heat continually rising up from Earth's hot core. This giant plume does more than heat up Iceland's hot springs. It also created Iceland itself. In 1963, there was an event which showed how it might have happened. A volcano just below the sea's surface blasted its way out of the water. A new island, Surtsey, was born. This is what Iceland must have looked like more than 50 million years ago, when it first burst above the surface. Iceland owes its existence to the plume of superheated rock beneath it. But it's also shaped by the Earth's inner heat in another, even more dramatic way. This extraordinary rock face at Thingvellir shows how. From the air, it's clear just how unusual this rock face is. It's a crack in the Earth's surface that runs as far as the eye can see. But even this is just a small part of something far bigger. To the left is a gigantic slab of the Earth's crust which runs unbroken for 7,000 kilometers. From here, under the Atlantic, across the USA, and all the way to California. It's what's known as the North American Plate. The Earth's surface is broken up into 7 vast chunks called plates. They're so enormous they can carry an entire continent, even extending under the ocean. Strip away the Atlantic, and the long boundary between 2 plates that runs along the ocean floor is exposed. Until it rises above the waves and cuts through Iceland, to eventually join up with the rock face at Thingvellir. These sheer rock faces were once joined together, but driven by the churning force of molten rock beneath them, the land was split apart. It happens because hot rock from the Earth's interior rises up. Near the surface, the rock spreads sideways in two directions. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move. The lava lake at Icela is an example of the same process, but in miniature. Convection currents move a skin of cooled lava across the surface, just as the continents are moved. To grasp this idea of continents moving, you have to step outside human timescales. The continents here in Iceland are drifting apart at 2 centimetres every year. In a human lifetime, that's just a couple of steps. But think in terms of millions of years, and it's clear just what can happen.